JSON is one of the most commonly used data structures for exchanging information. From websites to APIs to direct business-to-business information exchange, JSON is commonly used because it's compact and easy to read for both people and computers. But on first glance, it can be a challenge to understand the structure of JSON. And JSON syntax also relies on several rules that can cause issues in your data if you don't. I'll walk you through the basics of JSON syntax and use cases. I'll show you how to build your own JSON structures and introduce you to a few situations where JSON is commonly used. By building your understanding of a few concepts and mastering some simple tools, you'll be able to understand the structure of JSON data you work with. Let's get started. You don't need to have any particular background for this course. We will touch on some basic programming tasks, so if you'd like to familiarize yourself in advance, check out a course here in the library on programming fundamentals. We'll also be working with some JavaScript code in this course. You don't need to have a background in JavaScript to complete the course, but if you'd like to understand the essentials, a basic JavaScript course would be a great place to start. To complete the videos in this course, you need two applications, a web browser and a code editor. You undoubtedly already have a web browser installed on your machine, and any major browser, Chrome, Firefox, or Microsoft Edge, is fine for this course. I'll be using Firefox in these videos, which includes a powerful suite of developer tools. A number of great code editors are available, both free apps and paid ones. Any editor that lets you edit and save plain text is fine for this course. So if you have a code editor you like, such as Sublime Text or Atom, it's fine to use that. I use Visual Studio Code in these videos, which is a version of Microsoft's Visual Studio created specifically for web development. Visual Studio Code is free and has Windows, Mac, and Linux releases. The code is available on GitHub, and users can submit issues there as well. I've also installed one extension in Visual Studio Code, and that's Live Server by Ritwik Day. This is an HTTP server that you can launch with a single click, and that automatically opens the current HTML document in your default browser. This makes testing some of our code in the browser quick and easy to do. If you want to learn more about anything I use or talk about in this course, I encourage you to explore the library for a deeper dive on that topic. Now let's get started. JSON is a popular format used for sharing data online. The name is short for JavaScript Object Notation. JSON syntax is based on the JavaScript language, but you don't need to know JavaScript in order to use JSON. In fact, one of the reasons JSON is so popular is that you can use it in conjunction with most any programming language. JSON is widely used in a variety of common data exchange situations, including API requests and responses, and application configuration files. Before JSON was created, Extensible Markup Language, or XML, was a popular choice. But JSON quickly grew to eclipse XML, especially on the web, because of a few key advantages. One of JSON's advantages is that it's pretty easy for humans to read. For instance, this is one way to encode basic information about the country of Thailand in JSON and in XML. Both of these structures contain the same information, country name, capital, and area. But XML contains more extraneous characters and repeats the data label in both opening and closing tags. This not only creates visual clutter that interferes with human readability, but it also increases the number of characters required to encode the same data, meaning that XML data generally requires more bytes. This is a critical difference online because fewer bytes means a large file can be downloaded more quickly and browsers can display website content faster. Human readability and file size are two of the reasons that JSON has come to dominate data encoding on the web today. And that makes JSON an important syntax to understand for a wide range of roles that work with data, from computer programming to software configuration to data analytics and reporting. The acronym JSON stands for JavaScript Object Notation. The JavaScript part of that name is pretty straightforward. JavaScript is the programming language whose syntax forms the basis of JSON syntax. However, you don't need to know the JavaScript programming language in order to use JSON. The N for notation is pretty self-explanatory. Notation is just another way of saying that this is a way of presenting information with its own format and rules. But what does the O mean? Object. In this case, it's not the common sense of object, meaning just a thing, The word object in JavaScript object notation references a technical meaning of the word object. In JavaScript, like in other programming languages, an object is a collection of data that's similar to a list. An object contains key value pairs, where the key is a label that can describe the data, and the value is the data you're storing. For instance, suppose I'm making a list of my favorite foods. My favorite fruit is a mango. My favorite vegetable is an eggplant. And my favorite drink is sparkling water. I can make a list and specify a category and then the favorite thing. This is already most of the way there to creating an object in JavaScript. All I have to do is add the right punctuation so a JavaScript parser can understand the relationship between the items I'm presenting, and I have an object. In a JavaScript object, the label for a piece of data is known as a key. The data itself is known as the value. You'll often hear data and its label referred to as a key value pair. JSON is based on the way objects are written in JavaScript. JSON uses key value pairs and JavaScript object style punctuation, but with a few of its own rules added. Here's the object I created on the left, and here's how I would specify the same data using JSON on the right. Almost identical with a few differences. But it's not hard to see that JSON syntax is modeled on the notation that JavaScript uses for objects. There's another JavaScript data structure that can be represented as JSON. That's an array. An array is a list of values in order. You don't specify keys in an array, just values, and it uses slightly different punctuation. But under the hood in JavaScript, it's considered a type of object. And in fact, you can represent an array as JSON as well. The basic structure of both JavaScript objects and JSON that stores key value pairs starts and ends with a curly brace. For JavaScript arrays and JSON that stores an ordered list of values, the beginning and ending characters are square brackets. The array format has all the same rules as the object format, and objects are subject to a few additional rules. So let's compare a JavaScript object and its JSON representation. In JavaScript, the key doesn't require punctuation around it, but it's okay to specify it in single quotes or in double quotes. In JSON, the key must be surrounded in double quotes. So in JavaScript, I don't need quotes at all on the left, but in JSON, I do. In both, the key is followed by a colon. A value in a JavaScript object can store different types of data, including strings, numbers, true-false values, and even more complex nested structures like arrays and other objects. In JavaScript, a string value must be enclosed in quotes, but those can be single or double quotes, or even backticks in an ES6 environment. In JSON, strings must be enclosed in double quotes. No room for personal style here. In both JavaScript and JSON, you use a comma to separate one key value pair and the next. Numerical values don't need quotes around them in either JavaScript or JSON, but JSON has an additional rule for numbers. They can't start with 0. If this truly is a numerical value and the 0 doesn't matter, I can simply represent it in JSON as a number with no leading 0. But if the 0 is significant, I might need to represent this as a string instead, enclosing it in quotes and relying on the system receiving this data to work with it in that format. Likewise, a numerical value in JavaScript can end with a decimal point, but in JSON, this is not allowed. Usually, this just means that you need to ensure the decimal is removed. Boolean values, which have a value of either true or false, don't need quotes in either JavaScript or JSON. In a JavaScript object, it's common to put a comma at the end of every key value pair, even if it's the last one in the structure. However, JSON does not support trailing commas, so the final key value pair cannot have a comma after it in valid JSON. And so here I have the same number of key value pairs, and on the left in the JavaScript object, I have a comma after each final value. But on the right, in my JSON object, I have commas only after the first 3 when they're separating 2 different key value pairs. But in the final key value pair, I cannot put a comma at the end. Another feature that's supported in JavaScript objects, but not in JSON, is comments. You can insert a comment to explain or document your code in JavaScript, and it's ignored by parsers when the code runs. But JSON does not support any comment syntax, so you can't include comments in valid JSON. In my JavaScript object here on the left, I can include a comment that says legal approval. and that's just before the approved true key value pair. So in JavaScript, I use those two slashes to say, hey, this line's a comment. But in my JSON, I cannot include that comment, so I can only have the data that I want to include as part of the object. There are a few other technical details of JSON syntax that you might need to understand in specific situations. I think the JSON entry on Wikipedia does a great job presenting the technical details in a readable way. For a more technical reference, check out json.org. This site was created by Doug Crockford, who originally proposed the JSON standard. And there are a few variations of JSON that have slightly different rules. For instance, JSON-C is a variant that supports comments. If you're working with a system or team that supports a variant, then it's fine to use that, but keep in mind that for broad support with other apps and systems, the JSON standard is the most broadly supported notation. JSON is just text, so you can write and save JSON in any plain text editor. However, a code editor like Visual Studio Code can be really helpful when you're working with JSON because it includes tools that can point out some errors as you type, and it can also try to help you prevent making others. I'm in the highestfeatures.json file, and I want to create a JSON structure that stores the highest point, highest volcano, and highest glacier on Earth. Each of these needs a key for the label in addition to the value, so I need to use an object structure. An object structure starts and ends with curly braces, so I'll start a new one. And notice that when I type the opening curly brace, Visual Studio Code automatically adds the closing one. I love this because it makes it harder for me to forget to close my braces at the end. Another great feature, if I press enter immediately while my insertion point is still between the opening and closing braces, the editor moves the closing brace down 2 lines to the start of its own line, and on the line between the braces, it indents for me. Indentation makes code much easier to read, especially when you're working with a more complex nested structure. So having that done for me saves some work. First, I want to add the highest point. My label is point in double quotes, so I'll add that as the key. Then I need a colon and then the value, which is Mount Everest. The editor color codes the key and value different colors, which makes it easier to read the code and understand the meaning of each part at a glance. I have another key value pair after this one, so I'm going to type a comma. And notice with that red squiggly line under the comma and the changes to the red names on the left and on the top that the editor is flagging an error. Now I haven't done anything wrong, but the editor is letting me know that if I stop now, I'd have a trailing comma, which JSON doesn't allow. But I'll press enter, and I'll start entering my next key, which is volcano. The value for volcano is Ojos del Salado. And notice now that that error flag has disappeared because the comma I typed in the previous line is no longer at the end of my JSON content. Now I'm going to need another comma, so I'm going to go through that error highlighting again. So I need a comma at the end of my second line, and then one more feature on a new line, and that's glacier, and a colon, and the name is Khumbu Glacier. Now it's important that I don't add a comma here. It's the last item in my JSON structure, so I can't include a comma after it. I already have my closing curly brace, so my structure is finished, and I'll save it. Now that's an object structure, but what if I want to create a JSON array instead? Well, it's a bit different, but still pretty similar. I'll switch to the highestpeaks.json file. An array starts and ends with square brackets, so I'll type that opening square bracket. The closing square bracket is auto-completed, and I'll press enter when my pointer's between the two of those to get an indented new line between them. Remember that I don't specify keys in an array, just values in order separated by commas. So once again, I'm starting with Mount Everest in quotes, and then a comma. And on the next line, it's K2 and a comma. And then finally, Kangchenjunga. And no comma after this one because it's the final one. And that's my JSON array. In real-world JSON data, it's common to encounter structures with multiple layers. For instance, an array in which each element is itself an object. This file contains departure estimates for trains in the Bay Area Rapid Transit System in California. The starting curly brace indicates that the overall structure is an object, but many of the keys have additional objects as their values, and some even have arrays as their values. For instance, if I scroll down here, the estimate key contains an array with 3 objects in it. If the structure feels a little overwhelming, that's okay. It can be challenging to make sense of everything going on here, especially if you're new to JSON. To get a feel for how all the pieces fit, let's build out our own nested structure together. In the extremes.json file, I want to create a JSON object with 2 keys, highest peaks and lowest points. The value for each key will be an array listing the highest peaks and lowest points in order. I'll start by creating the basic structure. My overall structure is an object, so I'll start with curly braces. And then I want a highest peaks key, and I want the value to be an array. So I'll start some square brackets and I'll press enter. And for now, I'll just leave those square brackets empty. Now I want another key, so I need to put a comma at the end of the value for the first key, and that's at the end of the closing square bracket. And then on a new line, I want another key called lowest points. And again, I'll give this an empty array as its value. This is my basic structure. My next step is to fill in the next level of data, which is the array value for each key. Within the square brackets for highest peaks, I'll add Mount Everest, and then K2, and then Kangchenjunga. And then for lowest points, my values are Dead Sea, Lake Assal, and Turpan Pendi. Now I have a nested structure, which is an object containing arrays as values. Nesting gives JSON a lot of power because any value could itself be another object or array. You may hear JSON referred to as a notation for creating structured data, and nested arrays and objects are at the heart of those structures. Ready to try your hand at working with JSON? It's time for a challenge. My start code is a JSON file, and at first glance into my editor, it's clear the code has some challenges. The squiggly underlines all indicate places where the editor suspects my code is written incorrectly. Your task is to fix the errors in this code. There's an issue on each line, and although the editor may give you some help when you hover the mouse pointer over an error, it's not always going to be specific enough to explain what you need to do to fix it. There's an issue on each line, so use this list of basic JSON syntax rules, along with the editor highlighting, to figure out what might help. Then try it out. Remember that in debugging, fixing one error may change how others are identified. For this JSON snippet, try starting on the first line and working your way down. This ensures you're not trying to fix something that's being affected by an error earlier in the code. For instance, I see the word item flagged in the first key value pair. When I hover over it, I get a pretty helpful message. Property keys must be double quoted. I've got single quotes here, so I'll change those to double quotes. And now the error goes away. One down. If you want an extra challenge, add an additional key value pair to this structure with an array as its value. For instance, you could create a key called list price history and store a few numerical prices in an array as its value. This exercise should take you about 10 minutes. When you're done, join me in the next video and I'll walk you through how I approached it. So in my start code, I have a lot of errors, but remember I'm going to start from the top and work my way down. So in the previous video, we already looked at this one. Well, let's just do it again. We've got this error. It says property keys must be double quoted. Great, I can do that. So I'll replace those single quotes with double quotes. And now that first line is all set. So I'll look at the second line. Again, I've got that squiggle and I'll hover over that. It says value expected. That's not very helpful. But if I look at that and I think about my rules, I remember that, this is supposed to be a string, and strings are supposed to be double quoted as well. And this uses single quotes. So I'll change those single quotes to double quotes. And this is an instance where there was an error and the editor wasn't actually very helpful in telling us what was wrong. It just didn't see that as an actual value. But now we got that one fixed. So on the next line, if I hover over this issue, unexpected end of number. So it's pointing me to the end of the number, saying there's something weird. And if you refer back to the list of rules, one of the rules is that numbers can't end with a decimal point. So I can just take the decimal out here, doesn't change the value, it's still 84, and now that error goes away. So moving on, line 5, we got the error in the value, and this says expected comma. Now that's not super helpful. So let's think about this. This is a number, and we already corrected an error with a decimal, but there's one other rule in JSON about numbers. And that other rule is that they can't start with a 0. And this one does. So I'm going to go ahead and take that 0 off the beginning. It's called a leading 0 in this case. Again, it doesn't change the value. It's still a number. It's still 99.95, and the error goes away. Then on line 6, you may be able to spot this one even before I hover over it. This is one that we saw in earlier videos, but if I check out, it just says trailing comma. So right there, the editor is telling me exactly what's up. It's the last value, so I can't have a trailing comma on it. And now that error goes away. Now I still have one error on the last line. And again, thinking back to the list of rules, you may notice right away what's up here. It's the whole line. Let's see what the editor has to say. Exactly that. Comments are not permitted in JSON. Now I added this here as a reminder that if you want to do the challenge work, this would be the place to do it. But first, we have to actually take out that comment. And so here we go. This is that code, that JSON content with all of those errors fixed. Now, if I want to go ahead and do that challenge, the challenge was to add a key value pair that's actually a nested structure. And so to do that, first I have to add a new key. So I'm going to add a comma after my last existing key. And then my new key, I'm going to call that list price history. And I'm going to make that value an array in this case. Doesn't matter what, you can put objects within objects, you can put arrays within arrays. Here I've got an object structure and I'm going to put a nested array within it. So square bracket and press enter. And then I just want to add a few numerical values for my list price history. And I'm just making these up. So we'll say 94.95 and then a comma, and 85.00 and a comma, and 124.95. And I'll save that. And so now I have this array, the list price history array, which contains 3 values, and that is nested within this overall stock.json structure, which is an object. JSON data is generally shared as a string of characters, but JSON is useful as a notation because it can describe a structure, either an object or an array. So how does a programming language work with a JSON string? And how does it create a JSON string from an object or array? Programming languages need to convert JSON into a structure to use the data, and they need to convert structures from the language into JSON in order to share the data. You may see the terms serialize and deserialize used in reference to working with JSON. Serializing JSON means turning a structure into a JSON string, while deserializing is the reverse, turning a JSON string into a structure that a programming language can work with. Remember that even though JSON is based on the object notation used in JavaScript, JSON can be used across languages and platforms. Some languages like JavaScript and Python include utilities right in the language that serialize and deserialize JSON. In other languages like Java, you need to augment the basic features of the language with a library to manipulate JSON. Whatever language you're working in, you can check documentation or other resources for best practices on working with JSON data most efficiently. Converting a JSON string to a data structure is pretty straightforward. I'm going to show you what that looks like in JavaScript using the built-in JSON.parse method. But in general, no matter what language you're working with, the process of deserializing data involves passing the JSON string to the utility method, which returns the data structure. Remember that JSON can encode either an object or an array, But in JavaScript, as long as your JSON is valid and uses the notation correctly, the utility will understand what data structure is encoded and will return that. You don't need to identify what to expect beforehand. The H+ store populates page content using data from a backend database. This data is provided to the front end as a JSON string. The items.js file contains a snippet of that JSON string containing data about two products. I'm going to use the JavaScript JSON.parse method to convert this to a data structure. The products variable contains my data. On a live website, this would be the result of an HTTP request using something like fetch. But for exploration, I've hard-coded this in a file. I'll start by creating a new variable called products parsed. So that's const products parsed. And then I need an equals sign. And I'll set the value to the result of calling json.parse and passing the JSON string in the products variable. So that's JSON, all caps, dot parse, and then in parens, products. And that's a reference to the products variable above on line 1. I'll save those changes, and then I need to open up products.html, and I'm going to use my go live function for my web server to open that up in Firefox. And then I need to open my browser console, and one way to do that is just to right click and click inspect. That's going to open up the console. You may see it in a different part of your screen, but that's no big deal. And then just click the console tab, and you'll have this no matter what browser you're using. And so I can now type the names of variables that are used in my code for this page, and I can see their value here in the console. So I'm going to start by typing products parsed and press enter. And there's the array structure that's no longer a string. I can use this gray arrow to open it up, and I can see I have a couple objects in there. I can even use those gray arrows, open those up, and see all those key value pairs. Now for comparison, I can also view the original product string here. So I'll just type product on a new line and press enter. Oh, no, it's products with an S. And there's the unparsed string. In some browsers, you might instead get a parsed data structure here. And in that case, the browser developer tools are doing some extra work behind the scenes and automatically showing you the parsed version of that JSON string. If you wanted to see the raw JSON in a browser that was doing that, you'd need to check the settings for the browser and turn off that option that parses JSON automatically. But here I can see that that original variable is just a string. I don't have any sort of structure here at all in the console. It's just treating it as a string. So for this web page, that original products variable is a string, and the products parsed variable that I just created using json.parse actually has a data structure that JavaScript can see and work with. In JavaScript, json.parse works exactly the same if the JSON data structure is an object. So back here on my editor in items.js, I have the item variable down here on line 6. This is a JSON string that contains an object. So down here on line 9, I'm going to create another new variable. I can use const and call that item parsed, and use an equal sign to set the value, and it's going to be json.parse, and I'm going to pass in the item variable as the argument and end with a semicolon. And I'll save those changes. And then I'll go back to the browser, and in the console, I don't need to worry about this particular issue, but instead I want to look at the variable I just created. So I'm going to type item parsed, there it is. And if I press enter, I've got an object this time, not an array. If I click that gray arrow, I can see the structure, and the object has 4 key value pairs. So json.parse can deal with JSON data no matter which structure it's using. And now that I have my data parsed, I can work with it. So I can reference properties of this object, for instance, using dot notation. For instance, this item parsed object has a name property. So I can enter item parsed dot name and press enter, and the result is a string, which is the value of the name property of the item parsed object. So once the data is parsed, I can do anything I need to do with it in my application. When you want to transmit data, especially on the web, you generally need to convert it to JSON. There are other formats in use, so depending on the system you're sending data to, you may instead need to convert to one of them. Other popular notations for data sharing include YAML, which stands for yet another markup language, and XML, or extensible markup language. JSON is common, but by no means universal. So if you find you need to learn how to work with a different notation, check out a course here in the library to help you get started. But JSON is by far the most popular on the web. And whether you have an object or an array that you want to stringify into JSON, the process is pretty straightforward. In JavaScript, the built-in method is pretty self-explanatory, JSON.stringify. In JavaScript or any other language, the process simply involves passing the structure to the utility method, which returns a JSON string. When a user adds items to a shopping cart on the H+ web store and wants to order, the front end needs to stringify the shopping cart object and transmit it to the back end for processing. The cart.js file contains an array with sample shopping cart data. I'm going to use the JavaScript JSON.stringify method to convert this to a JSON string. The cart variable contains my array. On a live website, the object may be stored in a cookie or local storage, but for exploration, I've hard-coded an object in a file. I'll create a new variable down here on line 25, and I'll call that cart.json. And the value is going to be the result of calling JSON.stringify and passing the cart array in the cart variable. I'll save those changes and then open up products.html and use my web server to check that out in my browser. And I have the browser console open. And so at the prompt, I can type cart.json and press enter, and I see the string. Now, in some browsers, you may instead see a parsed version of the array here. It's something the browser tools are doing to help you out. So you can go into your settings and try and change that if you want to actually see the string here. But you can also just see on your screen here that cart.json, the result of the command we just typed, actually produces that JSON string. And if I look at cart instead, I can see that that's displayed as an array. So I definitely changed the structure of that content. JSON stringify works exactly the same with an object. And to try that out, the cart.js file includes a variable called single down here on line 27, which is an object and contains information on a single product. So down on line 39, I'll create a new variable, const, and I'll call that single JSON equals, and I'll use JSON.stringify, and in parens I'll pass in the single variable and end with a semicolon. And I'll save my work there. And back in my browser console, I'll type single JSON. And I can see here that I have a JSON string containing that object. So no difference in using JSON.stringify on an array versus using it with an object. Now that I have stringified JSON, I can include it in an HTTP request to the back end and keep the checkout process going for the user. That's super common on the web, and JSON strings are indispensable in exchanging data between browsers and servers and throughout the infrastructure of the internet. Ready to write code to process JSON data? It's time for a challenge. In this challenge, you'll write JavaScript to destringify an object and an array, and you'll also write JavaScript to stringify an object and an array. My start code includes two JavaScript files. Blog.js includes a posts variable containing an array. It also contains an article value containing an object. Your challenge for this file is to write JavaScript code that converts each value to a JSON string. The other JavaScript file, issue.js, contains a queue variable containing a JSON string that encodes an array. It also contains an item variable that contains a JSON string that encodes an object. For this file, your challenge is to write JavaScript code that destringifies each value into a data structure that you can work with in JavaScript. This exercise should take you about 5 minutes. When you're done, join me in the next video and I'll walk you through how I approached it. My first step is to stringify the posts array. So I have this array, it contains objects, and down here on line 17, I'm going to write code that stringifies it. So I'm going to create a variable first, and I'm going to make that posts JSON, and the value is going to be using JSON.stringify and passing it posts. And so that is going to stringify my posts array. Now, I also want to stringify the article object. And again, it's pretty much the same code. I just need to use a different variable name. So I'm going to use const article JSON, and I'm going to use JSON.stringify, and I'm going to pass it article. So let me go ahead and check just to make sure these worked. I'm going to open up my HTML file for this blog.html. Going to open that with my web server. So I've got the page loaded, and down in my console, I can check posts JSON, and I indeed have stringified version of that variable, and I can check article JSON, and I've got a stringified version of that object as well. So that code worked. And the second part here is in the issue.js file, and I just want to do the reverse. I have two variables here, and I want to destringify them. I want to parse them. So on line 4, I'm going to go ahead and write code that parses the Q variable on line 1. And so I'm going to create a const called Q data, and that's going to be json.parse, and then I'm going to pass it the variable name Q. And likewise, below, I have a variable on line 6, which is a JSON string containing an object. You can see that curly brace is the first character inside the quote. And so I'm going to create another const called item data on line 9, and the value is going to be json.parse, and I'm going to pass it item. I'm going to save that, and then back in my browser, I want to check Q data, and I have an actual array. The browser recognizes this as a data structure, so that's great. It's no longer a JSON string. And I want to check item data. That is an object that's recognized by the browser as a data structure rather than JSON string. So it's just using json.parse or json.stringify to go back and forth between JSON and data structures in JavaScript. And again, if you're using a different programming language, you're going to want to get familiar with the tools that do the same thing in that programming language. But generally, these tools are available, and you can easily convert data to JSON and JSON back to data. A common use of JSON data is on websites. Many websites you interact with regularly receive and send JSON data in the background in response to your interactions. For instance, as I type a query into this search box, the web page is sending what I've typed to the back end and receiving back JSON containing possible terms I might be searching for. Then the page displays those possibilities in the menu below the box, which enable me to quickly select my full query. Website data is exchanged using the Hypertext Transfer Protocol, or HTTP for short. When a web page sends data to the back end, it creates an HTTP request that specifies the web address where it's sending the request, provides details about the request format, and includes data, usually in JSON format. When the receiving system has processed the request and has an answer, it sends a response, which can include its own data. These requests and responses happen all the time for a lot of websites. When I place an order online and get a confirmation message containing my order number, that's generally data that just arrived from the back-end system in JSON format. I can view these requests and responses in my browser using the developer tools that are built into all major desktop browsers. I'm using Firefox, but these are available in Chrome and Edge as well. Probably the easiest way to open these if you don't use them all the time is to right-click anywhere on the web page and select Inspect. That's going to open up the developer tools. And once I'm there, I want to click Network. That's going to let me look at network requests. After I load a page, all the HTTP requests and responses for the information on that page will be displayed here. I'm going to open nps.gov, which is the web page for the US National Park Service. Then I'm going to open the menu, and I'm going to choose the events page. Now there are a lot of HTTP requests for this page, but I can filter those a little to avoid getting overwhelmed. HTTP is used for a lot of things on the web, but I'm most interested in XHR requests, which are a common request that returns JSON. In Firefox, I can click the XHR button right here, and now only XHR requests are displayed. And there are a few, but the one I'm most interested in is the Event Calendar service, which is here. Because calendars are updated regularly, it's common for a calendar page to load events as JSON and then add them to the web page. So I want to check out if that's what's going on here. So I'll click that line in the network list, and then over on the right, I'm going to click Response. And I can see right there, the data is labeled as JSON. I see the structure, which is an array containing multiple objects, and below that, there's a bunch of data for each object. And each object here is an individual event in the calendar. I can scroll down the web page and match up the event info with the data I see down in the JSON. These HTTP requests and responses happen all over the web, and a lot of the content that you interact with online every day was provided in an HTTP response as JSON data. To get JSON data from a remote source on the web starts with an HTTP request. We're going to work with the H+ Sport website, which is a site for a fictitious company that we're using just for this course. The H+ website displays a number of products that the company sells, with a name, image, and price for each one. All of this product data on the page is a result of an HTTP request for product data and an HTTP response that contains that product data. To make a request for data, I need to send an HTTP request to a specific web address called an endpoint. An endpoint has a program running that receives HTTP requests and generates HTTP responses back. For example, these are the URIs of two endpoints for the fictitious H+ Sport company. These may look like web page URLs, but instead of returning an HTML document to be displayed in your browser, they return JSON data. Now, building an HTTP request in a programming language can be a little complex, and it's beyond the scope of what we're doing here. But we can get a taste of what goes into an HTTP request and how it works without writing code, by simply entering the URL for an endpoint in a web browser and seeing what data we get back. That means that the browser is generating the HTTP request on our behalf. The H+ site supports a products endpoint that can return JSON containing data on H+ products. If I want data on all H+ products, all I have to do is send an HTTP request to this URL. So in my browser address bar, I'm going to go ahead and enter that URL. And when I press enter, my browser displays the data I get back, which is not a web page, it's just JSON data. Now Firefox automatically renders this, but the data that came in is actually JSON, unformatted, one long string. But it's much easier to read and understand when the browser automatically parses it for us. And so that's what I'm doing with these buttons up here. I've got the raw data button that shows me the raw JSON. There's a headers button that lets me see some components of the HTTP. But the JSON is really what's useful in understanding what kind of content is here. Keep in mind that although I'm using the browser to view this response data, requests to endpoints for JSON data are actually handled behind the scenes by web page code. So you don't usually see the raw JSON in the browser window. But once that JSON comes in, the web page code can work with the data it's received and format it to display it for users, like the H+ Sport page is doing here. After a program receives JSON data, it puts it to work. Depending on what the program is designed to do, there are all sorts of things it can do with the data, such as add it to a database, check it for errors, or format it and display it. To get a taste of the process, let's look at a web-based example. The start files for this video include web page files for the H+ Fitness company. If I open up products.html and use my web server to view that in the browser, I can see that the structure of the page is pretty bare bones, just the heading. But the page is supposed to display images and information about available products that it retrieves from a server as JSON. The script.js file is set up to fill in the product information. It begins with a variable called raw data, which is one long string of JSON data containing information on several products. In everyday code, this would instead use an actual server request that returns JSON data, but for our purposes, we'll assume that's done and the data has been fetched and stored in this variable. Further on down, the rest of the file contains code that takes data for each item and adds it to the web page. The only step that's missing is to parse the JSON into a format that JavaScript can work with. JavaScript uses the JSON.parse method to convert a JSON string to a JavaScript object or array. My script.js file includes a comment pointing out where in the file the JSON data needs to be parsed and stored, and that's right after lines 3 and 4. I just need to add a single statement. So on line 5, I'm going to enter const to make a variable. I'm going to call it data, and I'm going to set its value as JSON.parse, and then raw data, which is the variable name of the raw data at the top of the file. The result of parsing that raw data is stored in this data variable, and that variable name is used in the existing code that follows to retrieve information about each product and add it to the web page. So I'll save my work and I'll go back to my browser. And now I see all the products displayed based on the product information that was in the JSON string in my JavaScript file. So we got raw JSON data and then used a utility that's specific to this programming language, JavaScript, to convert the data to a format that JavaScript can work with. And then we use the data to do what the program was written for, displaying the data to end users in the web browser window. JSON is not the only data format in wide use, and sometimes when a program requests data, it's only available in a format other than JSON. Fortunately, converting is pretty straightforward in many situations. There are many data formats available, but aside from JSON, the most common include XML, YAML, and CSV. XML stands for Extensible Markup Language. XML is related to HTML, which is the markup language used to structure web pages. XML can be customized in ways that HTML can't, and it's been widely used for data exchange since before JSON existed. YAML stands for Yet Another Markup Language. You gotta love it when the name of a language to structure data can make you laugh. YAML was created with the goal of making structured data easy to write, and it has fewer rules than other data structures like XML. CSV stands for comma-separated values. It's literally characters separated by commas. CSV is often used for exchanging lists or tables. When a data source doesn't offer JSON, but a program expects it, you need to convert it from one format to another. To do this, you commonly use a library, which is a set of computer code that a program can call on to perform specific tasks. Different programming languages use different libraries for data conversion, and often many libraries are available to choose from. For instance, in JavaScript, you can use this XML to JSON utility. Now this is an older utility, and on the modern web, a lot of frameworks are in use that have this conversion capability built in. But for learning purposes, an older conversion tool like this is just the ticket. In my script.js file for this chapter, I have XML data stored in my raw data variable. This would generally come in dynamically by making an HTTP request, but for our purposes, I've included it to make the code less complex. Instead of simply needing to parse the data like I could do with JSON, I first need to convert it. I've saved the XML to JSON.js library file, and I've referenced it within my web page so I can use its utilities. This is a lot of data. And then eventually we get to line 2, and here's where I need to add some things. I first need to convert the XML string to a JavaScript structure called a DOM node. This is an intermediate step before I convert it. So I'm doing a var people data node, and that's going to be new DOM parser dot parse from string raw data text XML. Now I've used the documentation for this tool to understand how to write code that uses it. The next thing I need to do to use that tool is actually convert the XML in that DOM node to JSON. So I'm going to create another variable called converted data, and that's going to call XML to JSON and pass it people data node, and then a comma and 2 sets of double quotes. Next, I can parse the JSON data for use in JavaScript. So I'm going to create a const called converted object, and that's going to be JSON.parse, and I'm going to grab that converted data. Now, XML data uses an enclosing structure, so I need to dig into that structure to get the data I want, which is an array. I've looked at the structure, and I know how to reference that array. So I'll add one more statement to reference that array and save the reference with the variable name data. So that'll be const data, and that's converted object.data.product. So I'll save those changes. Then I'm going to open up products.html and use my web server to open that up in the browser. And now my product data is populated. That data came in as XML, but I used my library to convert it to JSON, which my program requires in order to display the data on the page. Data conversion sometimes brings challenges. If data picks up something as simple as an extra space while being passed from one system to another, or it's formatted in a way that the receiving system doesn't expect, then the conversion process may require some extra troubleshooting. So it's always best to request data in the format you need if that's available. But it's not always possible to get data in the format your program uses, and converting from one format to another is a standard part of working with data. As you start working with JSON, you'll likely start to encounter other terms with the word JSON in them. That's because JSON is used as a foundation for a few other technologies that rely on structured data. One web development approach you may encounter is JSON-P. JSON-P stands for JSON with padding. JSON-P is a technique for fetching data for a web page that's intended to work around some security limits that web browsers impose on web applications. One aspect of web security is based on origins, which you can think of as the web addresses associated with particular web apps. Web browsers prevent scripts from making requests to other origins. This is a same origin policy, and it's intended to prevent malware from injecting a request to another domain that accesses a user's sensitive information. It's a useful limitation, and on the modern web, servers have many configuration options that enable them to work with selected other domains they trust. But earlier in the web's evolution, this same origin policy was a blunt tool. JSON-P was developed as a creative workaround. As part of the site's own code, a statement is included that adds a script element to the page. Adding elements is totally allowed, even script elements. But this script element is going to load a script that returns data, and the data is formatted in such a way that the browser makes it accessible to the rest of the application. It's a neat trick, and some web services continue to support JSON-P. But JSON-P is not as secure as a standard request for data, and there are ways to accomplish everything that JSON-P can do while still maintaining security over all the data being transmitted. The most common approach is CORS, which includes using the access control allow origin header within your HTTP requests and responses. For this reason, it's best to use these alternatives rather than relying on JSON-P. Ready to explore the JSON data that powers some everyday experiences? It's time for a challenge. The developer tools built into modern browsers let you examine the code and data that are part of websites and applications that you open. For this challenge, pick a website that you use regularly or one you just want to understand better, and you'll use your browser developer tools to look at the data the site is receiving. Remember that you want to be sure to choose the XHR option in your developer tools to filter out other types of requests the browser is making that don't involve data exchange. In Firefox, you click the XHR button on the Network tab. In Chrome, you need to first click the filter icon, then click XHR. If you're not sure what site to examine, try the Louvre Museum in Paris at louvre.fr and open the Explore page. This exercise should take you about 10 minutes. When you're done, join me in the next video and I'll walk you through how I approached it. I'm going to explore some data on the web, and sometimes you need to actually open up the Network tab and start recording and listening for those HTTP requests before you actually open the site, just to make sure you get everything. So I've got a brand new tab here, and I'm going to start by opening those developer tools. There are lots of different ways to open the developer tools, but remember one of the most straightforward is just to right-click anywhere on the web page and click Inspect on the menu. And that's going to open up your developer tools. I've made mine a little bigger. You can just move the pointer over the top edge, and when it turns into that double-headed arrow, you can stretch that up, make it as big or small as you want. And then I want to go over to the Network tab, and I'm not worried about checking on this page, but now that I have this open, I want to go up to my address bar, and I'm going to go luvre.fr. And now as the web page loads for the first time, I'm getting everything. I'm getting all the requests. And so there's all the requests. I need to go ahead and deal with their cookie policy. So this includes all of the images, all of the JavaScript, all of the HTML, the fonts, everything that's coming on this page. There's an HTTP request for it. What we want to look at is the XHR requests, and that's the data. So I'm going to go over here and click XHR. And all I've got right now is a CSS file. So let's keep looking. I'm going to try the Explore tab. And now I can see that I have one JSON type here. So I'm going to go ahead and click this file. Actually, I don't want to click that link. I'm just going to click this entire line. And over here on the right, I can see some information about the request. So these are the HTTP headers, HTTP status, and I'm going to go over here to response to actually see what came in. So it's labeled as JSON, and if I start looking through it, I can see, first off, everything's surrounded by square brackets, so it's an array, and within the array, we've got curly brackets, so those are objects. So it's an array that's full of objects, and it looks like we've got elements of the menu, items that are on the page, got some encoded content, and that may be just images or icons. And so we can see that some of the things we can see in the JSON are on the page itself. And so this is just one instance where we can actually look at the JSON that's coming in and see that it's rendered on the web page. You can also check the What's On tab. And there I just got another JSON package. So I'll go ahead and check that out. So we can see we have a little menu here. There's something about news and programming, and that's right here. And then this image object is actually encoded within the JSON. We've got something on exhibitions, and that's right there. So all of this content is coming through as JSON and being rendered into the web page. So again, when you're exploring the Louvre website and a lot of other websites, behind the scenes, JSON is coming in and it's responsible for the content you're seeing. So JSON is super important on the web. And you can do this anywhere you go on any website. You can explore and see. Not every website's going to be based on JSON coming through to the front end, but a lot of them will. When an application makes data available, especially sensitive data like financial information, data security is an important concern. The JSON data an app provides in response to a request can be formatted in many ways. For instance, you can provide data that parses into an object, but your data can also be in the form of a JSON array or even a function in the case of JSON-P. Because some forms of JSON data can be evaluated as JavaScript by a client, you need to be aware of any security holes opened by different formats and take steps to mitigate them where necessary. Browsers enforce what are known as same origin policies. One of these policies allows a script to access data from another script only if both scripts share the same origin. The origin includes scheme, like HTTP or HTTPS, hostname, and port number, so this effectively limits a script from accessing data that comes from another server. Now, in some cases, I want to permit data sharing, and there are a number of schemes in use that let us do this. At the same time, I have to recognize any unintentional backdoors and be sure to lock them up. Same origin policies apply to code in a script. However, an HTML document can load scripts from any origin. Some attackers have taken advantage of this by running malicious code that adds a new script element to an HTML document. This is known as a cross-site script injection attack, sometimes abbreviated XSSI. By hijacking what the browser does after parsing data, malicious code can intercept data and send it to an attacker. Fortunately, there's an easy way to defend against this. Although a malicious script can add a new script element, it can't control what happens next. When the client downloads the script file, it immediately executes it. So many web services add JavaScript code that generates an error to the start of the JSON data they send. When the data is requested by another script, which can only happen in a script from the same origin, the script can parse the data and strip out the JavaScript code before using the data. But when the data is downloaded directly using an injected script element and the data is immediately executed, the malformed code at the start generates an error and the data is never parsed. One statement that causes an error, and that is commonly used for this purpose, is while 1. The statement creates a while loop that executes as long as the value 1 evaluates to true. Because 1 is equivalent to true in JavaScript, and because this statement includes no end condition, the statement creates an infinite loop. If the loop is allowed to run, it causes the client to stop responding. Alternatively, the client may have built-in logic that recognizes the loop and ends execution of the injected script. Either way, it closes off the possibility that the data object can be parsed and then intercepted by a malicious script. To deliver JSON that's prefixed like this, you have to configure your web service on the back end. But assuming that's already done, let's look at what it takes for your code to parse and then use this data. In the script.js file for this video, the protected data variable on line 1 contains data like you might receive from a web service. And this data is prefixed with the while 1 statement. If I open products.html and I go live, and then I open up my console, I can see that there's an error and that the contents of my web page aren't actually loading. And this is the behavior I want for my raw data. But I don't want to be parsing the data in this form. Instead, because I know that my data contains this extra while statement at the start, I can write code to edit that out and work with just the data itself. So I just need to create a function that removes the while statement from the start of the data and then parses the remaining data. So further down here on line 6, I'm going to add a function called cleanData. I need to start by making that a const. And then the value is going to take a parameter, which is raw data, and it's going to return the result of taking that raw data parameter and using the slice method to remove the first 9 characters. And those first 9 characters are the while statement. So this cleanData function is taking my data, removing that while statement, and then returning the rest of it, which is just the data. Then down here on line 9, I need to update my existing JSON.parse statement to use that cleanData function. So instead of simply parsing protected data, which has the while statement in it, I want to first call cleanData, and I want to pass it protected data. And the result here is that the protected data is going to run through the cleanData function, and the result of that is going to get parsed. And that will be just my data. And I'll save that, and I'll go back to my browser. And now I can see first off immediately that the products have loaded on my page, so the data is in use on my web page. I can also see that my console.log statements, first I'm getting that entire JSON string logged, and then next I'm getting just the data logged, which is the array containing all the information without the while statement at the beginning. You can ignore this other error statement down here. That's irrelevant for our purposes, just has to do with an icon that the browser is looking for. So again, because I'm operating from the same origin as the data source, I'm able to run code to modify it, and I can get the data out without being hampered by the error generating statement. And this should help prevent some malicious uses. Sometimes it's handy to have a JSON string in human readable format. For instance, when you're encoding a JavaScript object or array into JSON, especially a large one, you may run into problems that require debugging. It can be useful to examine the JSON string and identify where things go wrong. But JSON is not made for human readability, so examining the raw JSON won't necessarily do you any good. When I'm converting to a JSON string in JavaScript, I use the JSON.stringify method and pass it just the object or array to be encoded. However, the stringify method in JavaScript takes additional arguments, one of which is designed precisely for this purpose. After the value to be converted to a JSON string, you can optionally pass 2 additional arguments. The first optional argument is a function that modifies how the conversion happens. The second optional argument lets you specify indentation for levels of hierarchy within the encoded data, such as key names within an object. If you specify a number, then each successive level is indented this number of spaces. You can instead pass the string \t to use a tab. In the start files for this video, script.js contains the raw data variable, whose value is a large JavaScript object. And on lines 3 through 6, I'm logging that, parsing it over to a JavaScript object, and then logging it again. But I want to take that parsed data and I want to restringify it, and I want to use some of this formatting to see if I can make it readable. So here on line 10, I'm going to start by creating a console.log statement, another one, and I'm going to pass it json.stringify and my parsed object, which is in the variable data. But instead of stopping there, I want to add those indents so I can examine the string in the browser console. So after the word data, but before that closing paren, I'm going to add a comma, and then I need to add the second argument. Now I don't have a function that I want to use to modify the stringification process, so instead I'm going to specify null. And then I'm going to add another comma, and then my third argument. And this is the number of spaces to use for indents. I want to use 4 spaces just to make sure I can see those indents. So I'm going to enter the number 4. So I'll save that. I will open up my products.html file and use my HTTP server to open that in the browser. I'll open my developer tools, and in the console, I can see that I have readable content here for my last console.log statement. Now I can tell that I am actually looking at a JSON string because, for one thing, each property name is in quotes, and that's not the case when I'm looking at an object or an array. For instance, here, I can see when I dig into one of these sub-objects that these key values don't have quotes around them. But in a JSON string, the keys and the values have to be quoted when they're strings. So the other thing I notice here is there's no color coding. This is all black text on a white background in my case. And so I'm actually looking at a JSON string that's just been broken up and indented. And with those line breaks and indents, I can easily compare the stringified code with the code for the original object. If I was having a problem, I could compare the two, identify where things were going wrong, and then figure out how to solve the problem. When you process data returned from a call to a web service, a useful first step is to check whether any data has been returned. A JSON string will generally contain some characters, even if they're just the opening and closing braces for an encoded object or the brackets for an array. So parsing is a common first step. If you're using JavaScript though, checking whether the object or array is empty isn't as straightforward as checking for empty data of some other types. Unlike an empty string, for example, which is falsy in JavaScript, an empty object is truthy. This means that a simple logical test, like checking if the value is null, cannot distinguish between an empty object and an object with content. In a modern browser, you can use the object.keys method to generate an array of your object's keys, and then check if the length property of the array is 0. I've created a test file containing one empty object called emptyObject, as well as an object containing a key and a value called nonEmptyObject, and additional variables containing data of a few other data types: string, number, array, and date. So I'm going to create a new function called testData. And that's going to take a single parameter called data, and I'm going to add the statement if, and then in parens object.keys parens data.length triple equals 0. Then I'm going to console.log empty object and a colon, and I'm going to return the data. And after the closing curly brace here, I'm going to say else, and I'm going to console.log not an empty object and a colon, and I'm going to return the data. Now note that this code may behave unpredictably if it's passed data that's not an object. And in particular, a date object would have a 0 length here, so it would pass for an empty object, and I might skip parsing actual data. Now to account for this, I'm going to update my condition. So after, oh, and I realize I spelled this wrong, it should be object.keys plural. So after object.keys data.length equals 0, I'm going to do an and I'm going to use data.constructor triple equals object. And that would be false for a date object because that's constructed from the date constructor. So in theory, this function should be able to take each of my pieces of data and tell me whether they are an empty object or not an empty object. So I'm going to save my work here. I'm going to go ahead, and this is an HTML file. So I'm going to use my HTTP server, open this in my browser. I'm going to open my console, and then I'm going to test my variables. So I'm going to run test data, and I'm going to pass it empty object. And it is an empty object. It's been identified as an empty object. And so let me go ahead and do that again, but I'm going to test that against my non-empty object. And that's identified as not an empty object. And let's try it with the date variable. So that's date content, and that's also not an empty object. Now, where things get a bit more complicated is older browser support. And specifically, if we look at the compatibility table for object.keys, we can see that older versions of some browsers don't support the object.keys method. For instance, older versions of Internet Explorer. Now, I can write a more robust test using the hasOwnProperty method of the object. And if I look at the compatibility for that method, I can see it supports even older versions of Internet Explorer, as well as a number of these other browsers like Chrome and Firefox. It goes back to version 1. So we have really, really solid support here for any older browsers that might be in my user base. So I'll go back to my function, and I'm going to comment out this code that works in modern browsers. And I'm going to start with a for-in statement. So I'm going to do for prop in data. And within the for statement, I'll add an if statement, and I'm going to test whether hasOwnProperty triple equals true. And that's checking for the current property. And if that's the case, I'm going to console.log not an empty object. And I will return data. Then I need to account for both empty objects that pass through the for-in statement and non-object data that skips the for-in statement. So after this, I'll create an if-else construction. And this statement is going to check if JSON.stringify data is the same as triple equals JSON.stringify an empty object. And if that's the case, I'm going to console.log empty object, and I'm going to return data. Else, I'm simply going to console.log not an empty object and return the data. So I'll save my work here, and I'll go back to my browser, and I'm going to run tests again. So I'm going to call that same function, test data, and pass it empty object, and that is found to be an empty object. And running it with a non-empty object is not an empty object, and test data with a date content is not an empty object. And if I run it against the other data types, I'm going to see that those are also not seen as empty objects. And so I can use a function like this to test for an empty object. So this is going to be able to tell me whether I have data coming in response to an API request. What happens when you make a request for JSON data and the data you receive is different than what you expect? What if the JSON is organized differently than your code expects, or it's simply not a valid response to your request? To identify and deal with situations like these, you can use a schema. A schema is essentially a blueprint for what data should look like. You can create a schema for the data you expect to receive, and then provide that schema to the code that handles the data. Your code can compare the schema to the data and verify either that the data is the type you expected, or that there's a problem that needs handling. JSON schema is a standard for creating schemas for JSON data. It was created by the Internet Engineering Task Force. To create a schema using JSON schema, you create JSON using a specific structure and keywords, along with values you specify. You can then write code to validate data against the schema. What kinds of data problems can you identify with JSON schema? The specification has a number of options, but some of the most common areas include missing required data and incorrect types of data. For instance, Imagine if my app was requesting data that included a numerical invoice number and a billing total. Now imagine that I got this JSON as my response. Well, first off, I notice that there's an invoice num property, but there's no property that's obviously storing the billing total. So this data isn't exactly what I need because my code is expecting to work with a billing total. By validating, I can keep from taking the performance hit that comes with processing the data and then finding the error. Instead, I can identify the error up front and then perhaps resubmit my request or report the error. Now, the other thing I notice about this data is that the invoice num value is a string that includes both numbers and letters, but I'm expecting a numerical value. So even though I have data, it's of the wrong data type. Again, validating the data before processing it prevents potential errors or unexpected results that might come from trying to perform mathematical operations on a string value. It's also important to be clear about what a schema can't do for you. A schema allows you to describe the general structure of data, but you cannot use a schema to really delve into the meaning of the data itself to decide whether it makes sense. For instance, suppose you have JSON data for something like a shopping cart that includes a number of items and their prices, along with tax, shipping, and an order total. You can use a schema to verify that the price, tax, shipping, and total values are all numbers. However, a schema does not allow you to verify that, for instance, the total value is equal to the sum of the item prices and the tax and the shipping, or even that the total value is greater than each of its component values. For this kind of validation, you have to write code that works with and compares values. I want to create a schema to describe the product data available from the H+ Sport API. To start, I want to look at the data returned for a sample request. So I'm looking at data.js. Now this is the data I would normally get from an HTTP request to the API. But for the purpose of creating a schema, I've stored the data from a request in my file. Right now, this is JSON. It's a string, and the editor won't display it for me with line breaks and indents. But I can open products.html, start up my live server, and look at it in the console. So I'll go ahead and open that HTML file, start up my HTTP server, and then opening up the console. My project includes JavaScript code that parses the JSON strings into JavaScript objects and then logs these to the console. And now I can examine the structure of this data. It's an array, and it contains 6 objects, and each object contains the same 5 properties. I'm going to build my schema in the schema.js file. A schema is written in JSON, but it's easier to work with it by writing it as an object within the language I'm working in, which is JavaScript. But I'm going to follow the rules of JSON to make conversion easier. So I'll start by creating a variable. And so I'll just use var and call this product schema. And the overall structure of this is going to use opening and closing braces. The content of the schema is simply a set of keys and values, so a JavaScript object. By convention, I start with the $schema keyword as the first key, and this makes it clear that this object is a JSON schema rather than just generic JSON. Remember that JSON requires key names as well as values to be double quoted, so I have to put double quotes around this. And I'll follow that with a colon, and then the value, and this is a special value that's defined in the JSON schema specification, and it's a URI, that's http://json-schema.org/draft-07/schema hash. And this value indicates that this schema implements draft 7 of JSON schema. And I'll end this line with a comma, and on the next line, I also want to include the $ID property. This lets me specify a unique identifier for this schema. By convention, this is in the form of a URI as well, but it doesn't need to reference an existing resource. Generally, you want to use a domain you control and specify a unique path. I'm creating a schema for the products displayed on the H+ Sport website. So I'll use http h+sport.com schemas products.json. This isn't a valid URL at this point, and that's fine. As long as it's a domain I control, it provides a unique reference for the schema. And if in the future I choose to, I can publish the completed schema at this address. JSON schema also supports a couple additional properties that are optional but recommended. You use the title property to provide a short summary of the purpose of the schema. So I'll specify a value of H plus sport products. And then you use the description property to give a more detailed idea of the schema's use. So description, and I'll say schema for H plus sport product data. Looking at my data in data.js, I can see that at the top level, it has an array as its value. In my schema, I indicate the data type of the top level JSON content with the type property. So in this case, I'm going to say type, and that's going to be a value of array. Then for array data, I specify an items property, and the value of items is going to be an object, and it's going to specify what kind of data should be found within the top level array. So the items within that array are objects, and so I want to use another type keyword. So the type of data within here is object. So then I can specify the properties of each of those objects using the properties keyword. And properties is also going to be an object. And within properties, I can list each property name, that is to say each key name that occurs within these objects, and specify its data type. I can also give a lot of other information about each one of those properties, but for now I'm just going to specify the data type. So my first property is ID, and I specify its value as an object, but I only have one key value within that object, and that's type and string. And then a comma after that object value, and then I just need to go through all the rest of my objects. And so I can switch back to my console and just look here. I have ID, which I started with. There's also description, image, image title, and name. And I can do these in any order. The order doesn't matter within an object. So I'll just go with name next, and that's going to be a type of string. And all the rest of these are going to be string types. So I can really just copy and paste the code that I've just typed and change the key name. So I need a description. I need an image underscore title. And then I need an image. All 5 of those are strings, but if there were other data types like number, I could specify those here as well. And then I need to be sure, because this is JavaScript, I want to end my statement with a semicolon. Remember that JSON schema code is itself JSON. I've created this as JavaScript. My editor is able to recognize this as a JavaScript object and verify that the syntax matches what it should match for a JavaScript object. But again, it's important to recognize that this doesn't ensure that the schema I've written provides the validation I expect. That requires testing it against JSON that I know is good and verifying that each good JSON string passes validation with this schema. I also want to create some JSON that has specific errors and test those against the schema and verify that those errors are flagged. The easiest way to validate JSON data against a JSON schema is to use a validator written for that purpose. Free open source validators exist for a number of languages, including Java, Python, Ruby, and PHP, as well as browser-based utilities. For the H+ Sport website, I'll use a JavaScript validator called AJV. AJV is designed for back-end use, but I can try the tool out without installing it by using an online instance called a REPL. The left pane shows the JavaScript code that the validator uses. I only need to work with 2 parts of the code, the schema variable and the test function calls. I'll open the schema.js file for this video, and I want to copy the schema content to the clipboard. Now I only want the object itself and not the variable declaration or the equal sign. So I'll click at the beginning, click at the end but not include the semicolon, and copy that. And then over in the REPL, I want to delete the existing value for schema and paste in my schema. Now that I've told the REPL what schema I want to validate against, I need to give it some sample data to test. To do that, down here on line 34, I can call the test method and specify the value to test against between parentheses. So I'm going to start by deleting the existing values between parentheses for the first function call. And I'll just delete the second function call altogether for right now. Then I'll go to my data.js file, and I'll copy the value for the raw product data variable. And this is a JSON string containing an array. So I want everything from the opening quote to the closing quote, but not that closing semicolon and not the variable name and the equal sign. Copy that to the clipboard, and then over in the REPL, I'll paste that between the parens after the test function call. And now I'm ready to test, so I'm going to scroll down all the way to the bottom and select the Run button. So this is telling me my data has to be an array, and it looks like my error here is that I included the quotes when I wanted to just give it the data instead. So now I've just pasted in an array rather than a string containing an array. And I'll go ahead and click Run again. And this time I get the message valid. So my data is valid according to the schema I created, which is exactly what I expect. Now what happens if there are errors in my data? I would expect that to be invalid, and I can test that out. So I'll go back to my data, I'll introduce a couple errors, and I'll make sure that those get logged as I expect. So in the code for the first product, raspberry mineral water, I'm going to replace the description value, which my schema specifies has to be a string, and I'm going to replace that with a number. And for that to be a numerical value, I have to take the quotes off. Remember that only strings are quoted in JSON. And then here for the second product, strawberry mineral water, I'm going to take the quotes off of the ID value. So my schema is expecting a string value for the ID, but I'm going to throw a number at it and see what happens. So I'll scroll down and I'll click Run again. And this time I get the message invalid, followed by a couple specific messages. And the validator is pointing out the errors that I introduced exactly. Description must be string, ID must be string. A validator is really helpful in making sure your schema matches the data that you want to work with. And it can also flag errors in data coming in before you try to work with the data. In addition to specifying data types for the properties of JSON data, JSON schema also allows you to specify that one or more properties are required. At this point, my schema specifies a data structure for an array that contains objects, and each object contains 5 properties: ID, name, description, image title, and image. What if I want to require that these properties must be included in order for my JSON data to be considered valid? Well, remember that each sub-object within the array is itself specified by an object in JSON schema, with a type property set to object and a properties property specifying the names of properties it can contain. To indicate that one or more of these properties are required, I simply add another property to the object in my JSON schema. The property must have the name required, and its value is an array containing one or more strings as its elements. Each string in the array must correspond to a property defined in the properties object. In my schema.js file for my items property, I already have a type value of object and a properties value containing the properties to include with their data types. To specify that all of these properties are required, I add another property after that data structure. Because I've got so many nested braces here, I'm going to click the curly brace after the properties key, and that's got a box around it, and my editor is going to highlight the closing brace for that, which is down here on line 26. So I'm going to click at the end of line 26, I'm going to enter a comma, and then I can enter another key value pair that's on the same level as the properties key. And the name of this is going to be required. And I'm going to set the value of the required property to an array. And in that array, I'm going to add 5 elements, which are strings containing the names of the required properties. And these can be in any order. So ID, name, description, image underscore title, and image. This code specifies that some value is required for each of these 5 properties within each object for each product. Now I want to test this. So I'll save my changes to the schema, and I'll copy the value of the product schema variable without the quotes. So starting at the curly brace after the equal sign and at the very end, before the semicolon. And then I want to open up the validator I'm using, which is AJV, and I need to swap out my new schema value for the schema variable. So I'll select that schema variable and paste mine in its place. Then back in my editor, I'm going to open up the data.js file, which contains my data. And I want to copy the value of the raw product data variable without the quotes. So after that opening apostrophe, and all the way down to the end of the line, excluding that closing apostrophe and semicolon. And I'm going to copy that to the clipboard. And then over in AJV, I'm going to scroll down to lines 41 and 42. I'm going to delete that second test function call on line 42. Whoops. There we go. And within the parens for the test function call on line 41, I want to select the contents. And then I want to paste in what I just copied. And now I can scroll down and hit run. And after a moment, I get the message valid. All of my required properties are included throughout the data. Now, all of my data currently contains all 5 properties, but I can test my schema by deleting a few properties here and there. So for my first item, I'll delete the image key and its value. I seem to have some scrolling behavior going on when I click in here, so I'm just working around that the best I can. So there's the image key and value and the comma after it. And then for the next property, I'll just go ahead and delete the ID key and value and the comma after it. And I'll scroll down and I'll click run, and I get an error. So it says invalid, and it has 2 messages about specific elements of the array that are missing, and in particular, that there's a required property image and a required property ID, which are exactly the 2 I deleted. So I'm really happy to see this error message because it means the schema is catching potential issues that are important to me. And now, in addition to catching potential issues with incorrect data structure, extra data, and incorrect data types, my schema also catches missing data. Building a JSON schema from scratch can be a challenging and tedious process. You can get a leg up on coding the components and the basic structure, though, by using a schema generator, like the one at JSON-Schema.net. A schema generator allows you to enter an example of valid JSON that you want to validate and choose some schema options. It then automatically generates a schema that fits your data and any selections you've made. The H+Sport API can return a number of different categories of data, including data on people. In the code for this video, the data is stored in the data.js file in the raw person data variable, which is on line 3. It consists of a single property, cards, containing an array of objects. Each object contains 3 properties, and 2 of those properties contain sub-objects as values. So there are a number of levels in this data and several different properties scattered throughout. Instead of trying to build out a schema from scratch, I'm going to select and copy the JSON from the opening curly brace to the closing one. So again, leaving off the quotes, going all the way down to the bottom. And I'm going to copy that to the clipboard. When you open the main page of JSON-Schema.net, you may be asked to create an account, but there's also an option to just continue as a guest, and that's what I've done here. So the left side of this app is the JSON section, and the right side is the resulting schema. So I'm going to start by selecting the contents of the JSON box and deleting those, and then I'm going to paste in the JSON I copied from my web page code. Notice that the tool checks for valid JSON and confirms that I'm good to go on that front with the notice just above the JSON box. It says your JSON is valid and gives me a green check mark. If I click Settings up here near the top of the left column, I have a number of options, and I want to customize a couple things. First, I'm going to click Keyword Visibility, and this lets me select whether certain keywords are included in the schema. Examples is selected by default, which can be useful in understanding a schema you didn't create or haven't worked with in a while. But the examples can make the overall structure harder to understand. So for now, I'm going to uncheck that. And then I'll click outside that list to close it. I also want to customize the URI for the schema. So I'll select the value in the absolute URI box, and I'll delete it, and then I'll enter the one I've been using, http://h+sport.com/schemas/person.json. And so this is different than the one I've been using actually. This is specifically for the person data. And then I'll click Save to save my selections. And then at the bottom of the left pane, I'll click Submit. And the tool is generating JSON schema code based on the JSON data I pasted. And now on the right side of the app, the box displays the newly generated schema. And as I examine this code, I notice a couple things. First, it includes a $schema value by default, along with $ID, type, title, and description. So these are all metadata keywords for the schema. And as I scroll through the data, when I start looking at things, I notice that every property that was included in my data is marked as required. Now in my case, those properties are all required, and so I'm fine with what's gone on here. But if any of them weren't required, I could simply remove that extra keyword. Also notice that in addition to the description property for the root structure, all of the other properties in my schema have a description property as well. This can be useful for documentation purposes. At this point, the schema generator has fulfilled its purpose, which is to take care of the bulk of the tedious work and get me most of the way there. So I can copy the code for the schema from the right side of the app, and it actually has a copy to clipboard button, so I don't have to select it first. Then back in my code in my editor, I'm going to open up schema.js, and I'm going to add a new variable for my person schema. So at the bottom, I'll say var person schema, and I'll set that equal to the value I just copied. So I'll just paste that in, and I'll add a semicolon at the very end for completeness. And then scrolling up, I'm going to look at the very first meta properties. So on lines 41 and 42, these are just very generic title and description. So for the title, I want to change that value to H plus sport people. And for description, I want to change that value to schema for H plus sport person cards. Now that I have a schema for my data, I'll open up a schema validator just to verify that it works as I expect. And I've been using a live version of AJV that's hosted online. I'll copy my edited schema, and that's just the value, so everything within the curly braces, including the curly braces. And then over in my validator, I'll paste what I've copied as the value of the schema variable. And then back in my code, in data.js, I want to copy the value of the person data variable. That's raw person data. So that's everything but the quotes. And then scrolling down within my validator, delete the second test function call. And then in the first test function call, I'm going to delete the contents of the parens, and I'm going to paste my data within the parens. And then I want to scroll down and click the run button. And after a moment, I should see a response here. Now I have an error here, and it looks like the schema validator disagrees with the inclusion of the additional items property at the root level because the object is not an array. So back in my editor, I'll go to schema.js and I'll go to my person schema. And down here on line 54, I'm going to go ahead and delete this line. So it's automatically added by the schema generator, but I'm going to save that here. And I will once again copy the value of person schema and go over to my validator and paste that in again. I could just make the changes in the validator, but there's a real concern there that I might make the changes there and forget to save them in my file and then end up with a schema that I'm using that doesn't match the one that actually passed validation. So with my new schema here in place, I'll go down and I'll click run again to wait a second for that to run. And now I have valid. This is why it's super important to test even a generated schema. Sometimes that includes simply making sure that your schema works for what your schema validator expects. Even with the little change that I needed to make, I have a schema for person data that took relatively little work to create. So schema generators are a really useful starting point for building schemas. Ready to try your hand at working with JSON schema? It's time for a challenge. The start code for this video includes JSON data returned from an API that provides weather forecasts. Your challenge is to create a schema that validates data in this structure. It's fine to use a schema generator for this challenge. However you create the schema, customize it with the URI shown here for its ID. Once you've created your schema, save it to the schema.js file as the value of the weather schema variable. Also validate it using a schema validator and make any adjustments to the code so it passes validation. This exercise should take you about 15 minutes. When you're done, join me in the next video and I'll walk you through how I approached it. I want to create a schema for my weather data. And just looking at this data, even without it parsed, it's got a pretty complicated structure. So I'd prefer to just use a schema generator. Now, if you want an extra challenge, sitting down, parsing this data out, and then building out level by level your own schema is a really great challenge. But I'm going to walk through just building this out using a generator. So I'm going to start by copying the content between the quotes. Take that to the clipboard. And then I'll go over to JSONschema.net and I'll replace the existing JSON with my JSON. And I will go ahead and make a couple changes to the settings. So in keyword visibility, I want to take those examples out just to make the structure easier to read. And I want to change that URI to the one that I specified for this particular schema. So that's http://explorercalifornia.com/schemas/weather.json. And then I'll go ahead and save that. And I will go ahead and submit. And now I have a generated schema on the right. I'm going to go ahead and copy that to the clipboard using that button. And back in my code, I'm going to go to my schema.js file. I'll just take those curly braces out and I'll replace those with the generated schema. Pretty big. So I'm going to go ahead and save that. And now I actually want to validate that this generated schema makes sense and that it actually works for what I want to do. So I've still got that schema on my clipboard. So over in my validator, which is AJV, I'm going to go to the schema variable. I'm going to select that value and delete it. And I'm going to paste in my schema. And then down near the bottom, I want to take out the value for the second, actually I want to take out the entire second test function call. And I want to take out the value of the first test function call. So I have empty parens. And then back in my files, in the data file, I want to go ahead and copy everything between the quotes. And then back in my validator, I'm going to paste that between the parens. And then scrolling down, I'm going to click run and see what I get. And in this case, looks like I got an error similar to the one that I got in the lesson itself. I have additional items that the schema generator threw in there and that the validator is not feeling good about. So I'm going to go back to my schema in schema.js and I can see I have additional items here on line 9. I'm going to take that out and I'm going to do a search and just make sure. And I have another instance of additional items on line 116. I'm going to take that out as well. And it looks like there's nothing else matching addition here. So there were 2 instances of that. I took them both out, saved my schema. And now I want to copy just the curly braces and everything between them. I'm going to go back to my validator, scroll up, and replace the value of the schema variable. That's down through line 215. So we'll delete that. And then I will paste in what I copied. So this is my updated schema without those 2 statements that the validator wasn't happy with before. I'll click run again. It can take a second for those old results to clear. And this time I get valid. So again, I generated a schema using sample data, Then I validated that schema, and I chose to accept the recommendations of the validator, which were different than the recommendations of the generator. You can create JSON structures and schemas for a wide variety of data, but when you're sharing that data with another organization or receiving data built by someone else, it often takes human intervention to classify the content and decide how to integrate it. You can make it possible to automate tasks like this by adding semantic markup to your data. Semantic markup not only organizes the data, but indicates its meaning using a common vocabulary of objects and key names. On the web, a number of semantic systems have been used, including RDFA and microformats. Another popular semantic system based on JSON is known as JSON-LD, which stands for JSON for linking data. JSON-LD follows the rules of JSON, but adds a couple standards to convey the meaning of content. First, it references common vocabularies that are maintained by a variety of organizations, including schema.org, productontology.org, and the W3C. Data built on the JSON-LD standard also implements key names based on the vocabularies that it references. Together, these two JSON-LD features enable an application to parse data and make decisions about what it contains and how it should be used. For instance, Google encourages websites to include JSON-LD in their HTML to provide page content summaries for search results. JSON-LD also enables applications to examine data from multiple sources and identify how they relate to each other. For instance, if I was building an application that requested data about cars for sale from multiple websites and displayed a single searchable list, I might find that the data I received used different key names. This could make it difficult to write code that could reliably recognize when two different cars for sale shared a make, model, and year. Is make the same as brand name, for instance? If both of those information providers used JSON-LD, my application would be able to recognize that the data received is structured based on a common standard, and it would be able to correlate values based on their shared key names. This can be especially helpful when retrieving different types of data about a common item from different sources. For instance, if I wanted to compile information on organizations for job seekers, one source might provide a company's location and number of employees, while another might give me information on the company's diversity policy and ethics policy. If both sources provided data structured with JSON-LD, I would be able to recognize the company name as a shared value between both datasets, and I could reliably compile all values together into a single merged record. By combining semantic meaning with the widely used JSON data structure, JSON-LD enables data to be combined and used in a variety of new ways. Common vocabularies exist for many popular types of data, and JSON-LD supports tagging data using vocabularies from a variety of sources. To specify a vocabulary for a JSON object, you use the special @context key name. Each vocabulary has its own namespace identifier, which is a URI. This is a string that looks like a URL, but may not correspond to an actual live resource on the web. However, the identifier is unique and can be used programmatically to correlate multiple pieces of JSON-LD data that use a common vocabulary. The start files for this video contain a JSON object containing basic information about the H+ Sport Company, and that's stored in the snippet.json file. I want to convert this to a JSON-LD snippet using a public context. Schema.org defines contexts for a number of generic types of data. I notice the Things section here includes an Organization section, so I'll select that to explore it. Schema.org vocabularies can require a little familiarization. There's a lot of information here. In general, Schema.org vocabularies start with a list and description of key names that are specific to the category you selected. Here, organization. Then they may be followed by a list of other relevant key names from the parent category that are relevant. Here, the organization vocabulary uses keys like name and image from the more generic thing category. To build a schema from scratch, it can be useful to start with a model. The JSON-LD playground is provided by the organization that maintains the JSON-LD standard, and it gives examples for a number of common categories. It doesn't show organization, but I'm going to select person. And at the top of the window, I have JSON-LD input, a model to build on. I see the context is simply http://schema.org. Then there's an @type key that indicates the vocabulary within schema.org that's used here. After that, The keys match the names in the schema.org documentation for a person. So I'm going to try this out with my code. First, I'm going to select all of my JSON from snippet.json. I'm going to copy it to the clipboard. And then over in snippet.JSON-LD, I'm going to paste it in as a starting point. The JSON-LD file extension lets the editor know that it should parse the contents as JSON-LD. On the JSON-LD playground, in the JSON-LD input box, I can see at the top that I need a couple special JSON-LD keys. First is @context, which is going to be the same as what's shown for the example, that schema.org URL. So I'm going to insert that at the top, @context, http://schema.org, and make sure to include that final slash. Without that, the context value isn't valid. Then I need to put a comma at the end. And the next key I need is type, and that's an @type. Now I'm not defining a person, but an organization. And back in my browser, if I go back to the schema.org page for organization, I can see right at the top it says organization, a schema.org type. So I know I can use the word organization as my type value here. So I'll go back to my code and use organization for my type name. Next, I need to make sure the data I'm providing uses keys defined by the organization type. First, company. So I'll switch over to the organization list, and I can see that's not in the list. But I've spent some time looking at this, and if I actually scroll down to the properties from things section, there's a name key, and that's the same as for the person type. So in my snippet, I can simply replace company with name. Next, I have website, and back in the list of keys for the organization schema type, I can see this isn't listed either. But it's a common type of data for both a person and an organization. And so again, if I scroll down, I can see that the URL value is again listed in the things section for organization. So in my snippet, I'll replace website with URL. Next, I have image. And it's important to understand just what this image is. And in this case, it's the company logo. Back on the schema.org page, if I look through the list of keys, I can see that there is a logo value. And its description matches what I have. So back in my code, I'll replace image with logo. And finally, I have overview. This is a summary of information about the company, what it does. Again, a pretty common type of data for a number of types of information, not just an organization. And so I'll look at that things section again, and there's a description key, and that seems to match what I need. So back in my code, I'll replace overview with description, and I'll save that. Now I've converted my organization overview to use the public schema.org organization type, and I've implemented key names for my data that are specified for this type. I could share this data on my website or with other companies, and it would be clear from the information provided here that I'm specifying the company name, URL, logo image, and a company description. No need for anyone to guess what this data means. Sometimes it's not realistic to change the key names in JSON data that you want to share. For instance, if you want to simply provide data from a large database you maintain, and you already use a set of key names that are different from those in the public context and type that you want to use. For this situation, JSON-LD supports a different type of structure. Instead of renaming your keys, you can include an additional object within your JSON-LD snippet that maps your key names to the key names used in the context and type that your snippet references. I'm going to try this out with the company overview for H+ Sport. I have snippet.json open, which is the data that I want to convert to JSON-LD format. And so I'm going to select that and copy it to the clipboard. And then over in my snippet.json-LD file, I'll paste that in. And now I need to convert my content to use JSON-LD standards. So I know that the first thing I need to do at the top, I want to add an @context keyword. But instead of simply providing a URL, this is where I specify the object that maps my keys to the vocabulary keys. And so the value here is going to be an opening curly brace. In my editor, I can just press enter, and I get a blank line and the closing curly brace on a new line. And then after that closing curly brace, I need to make sure that I include a comma to keep my format correct. And I'll save that change. Now within this sub object on line 3, the first key that I need to add is vocab. And that's where I'm going to provide the schema.org URL. So that's going to be @vocab. And the value, again, is http://www.schema.org. And I need to include that final slash after org, and then a comma at the end of that line. Next, I need to specify the same keys that are in my data: company, website, image, and overview. And for their values, I need to provide the corresponding schema.org key name for each of those pieces of data. I've already looked these up, so I'll start with company, and the value is name. And then for website, I know my value that I need to use is URL. Then I have an image key, and that maps to the logo key for the schema that I'm using. And finally, overview, which corresponds to description. The object I just created provides a map between my data below and the keys at the URL referenced by the @vocab key. My company key maps to the schema.org name key. My website key maps to the schema.org URL key, and so on. I need to add one more piece here. After the @context object and before my data starts, I want to add the @type key and specify the schema.org type for this data, which is organization. So that's before company. I'll add @type, and the value is going to be organization, and a comma at the end of that line. And I'll save this. I'll select it all and copy it to the clipboard. And then I'll go to the JSON-LD playground online. And in the input box, I'm going to paste this. This checks for basic syntax errors, and I don't have any, so I'm good. Using this JSON-LD format lets me take data that I already have and indicate how it should be interpreted, but without needing to redo my own internal systems for tracking my data. And that's important, especially when I want to use the data for different purposes, and one set of keys is never going to satisfy all the different uses. JSON-LD can be relatively straightforward to write for small snippets, but for larger content or content that relies on more than one vocabulary type, automatic JSON-LD generators can save you a lot of time. Generators still rely on you to identify the content that corresponds to each key, but they generally provide an interface for common vocabulary types where you can enter your data, and then they generate the resulting JSON-LD snippet for you. H+ Sport is hosting a 5K training run. The event will be listed online, and I want to create a JSON-LD snippet to make it easier for search engines and event aggregators to identify the relevant information and show it to people who might be interested. I haven't created JSON for this event, and I'm going to try creating the JSON-LD directly using a generator. I found this JSON-LD generator using a web search, but if you have any trouble opening it, just search for Generate JSON-LD in a search engine and identify a tool from the results. This generator supports a number of common categories of information. There's an event option, so I'll select that. On the left, I have fields where I can enter my information, and on the right is JSON-LD code based on the form. I can see that the event type is already part of the snippet. There's also a nested location array that includes a separate virtual location data type. In the files for this video, I have an empty 5ktraining.jsonld file where I'm going to put my generated JSON-LD snippet. I also have a 5ktraining.txt file which contains the text from the flyer. I'll use that to add content to the generator. So first up is the event name, and in my text, I have the event name 5K training run. So I'll paste that in. Once I paste that in, I can see that over here, the name field is populated with the value I pasted in. The description is also part of my flyer, so I'll copy that and paste it, and that's generated over here as well. Now I don't have data that corresponds to all the suggested fields here. For instance, I don't have an image URL. For attendance mode, I have the choices of online, offline, or mixed, and this is definitely going to be an offline event. It's not going to be online. It's a training run. And the status is scheduled, so I have room to specify the start date and time and the end date and time. So my start date is June 13th. The end date's the same. And I have a little calendar widget here I can use to select that. I can actually use any date here. That's not super important just for trying this out. But let's go ahead and say June 13th for the start date and for the end date. And this is 12 noon to 2 o'clock p.m. So for the start time, I need to use a 24-hour format. So that's going to be 12:00. And for the end time, that's going to be 14:00 for 2 o'clock p.m. The last thing I need to enter is the location. It's the last piece of information on my flyer that I haven't entered. So I'm going to copy that location, Ramsett Park, and put that in the location name. And now I've generated all of the JSON-LD for all of the information about my event. Each of the pieces of information I have has been tagged with one of the key names for the schema.org event type. And so next I want to copy my JSON-LD code and paste it over into my file. Now, this generator automatically generates opening and closing script tags for an HTML file, but we're not putting this in HTML. We're going to keep this as just a JSON-LD snippet. So I want to copy everything except for the first and last line here, everything but those opening and closing script tags. I'll copy that to the clipboard. And then over in my editor, in my 5K training.json-LD file, I'm going to paste in that code. Now I do notice that down here in the location section, I have all this information about the address that I haven't actually filled in. I just gave a name of a location. And so I'm just going to go ahead and take out this entire address section because it's not necessary for my data and it doesn't really add much. And I need to take out the comma after Ramsett Park because it's the last key in this sub-object. And I'm going to save, and that is my completed JSON-LD snippet. Using the generator, I was able to create a JSON-LD snippet for somewhat complex data without a lot of work. So that was a really great time saver, and now I'm ready to share this snippet wherever I need to. JSON-LD has a variety of uses. Perhaps the most common way that many of us consume JSON-LD content is on the web, where JSON-LD snippets may be displayed as part of search results. Adding JSON-LD to a web page uses the same script tags that are used for JavaScript. However, while the JavaScript file type is application/JavaScript, the type for JSON-LD is application/LD plus JSON. An HTML document contains two main sections, the head and the body. The head contains information about the page, while the body section includes the content that is rendered by a browser or other user agent and presented to the user. The JSON-LD goes in the head section. The snippet.json-LD file for this video contains a snippet for the H+ Sport Company. I want to add this to the product page for the company website, so search engines can use the information when indexing the site. So opening up the products.html file, at the very top of the file, I have the doc type on line 1, followed by the opening HTML tag, and then the opening head tag on line 3. Several lines later, on line 9, is the closing head tag, which includes a slash before the word head. My first step is to add a script tag for my JSON-LD snippet anywhere between the start and end head tags. I'm going to do that at the very end of the head section, so I'm going to add a new line below line 8, just before that closing head tag. And I'm going to type script type equals, and then in quotes, application/LD plus JSON. Close the quotes, close my angle brackets, and then my editor immediately adds the closing tag for me, so I don't forget to type it. I'll press enter, and I'll press enter one more time, and now I can go up to the blank line, I can indent, and now I'm ready to add my snippet. So I'll switch to the snippet.json-LD file, I'll select everything, and I'll copy it to the clipboard, and then back in the products file, I will paste that in between those script tags. I got an extra blank line on line 23, so I'm going to take that out. The indent makes it clear that all of this content occurs between the opening and closing script tags. I will save those changes, and now my web page includes a JSON-LD snippet summarizing basic facts about the company, which can help search engines index the page. It's common for tools that generate JSON-LD to include the opening and closing script tags automatically in the code they generate. This lets you simply copy the generated snippet and paste it into the head section of an HTML document. Ready to build your own JSON-LD snippet? It's time for a challenge. The start code for this video includes an empty person.json-LD file. Your challenge is to add JSON-LD code that describes a person to this file. You can build a snippet that describes you, or you can pick a well-known person to build a snippet for. Your code should include at least 3 properties, so be sure to do research if necessary. Wikipedia displays a number of quick facts about famous people, so that can be a useful resource for this exercise. You can build your JSON-LD using the playground at JSONLD.org, or using a generator, or you can create it from scratch. For an extra challenge, add a second level of data using a nested data type. You can refer to the person documentation on the schema.org site to learn more about nested data that's available for a person object. This exercise should take you about 10 minutes. When you're done, join me in the next video and I'll walk you through how I approached it. I could generate my JSON-LD for a person using a generator, but I'm going to build it myself just to take it step by step what needs to be in the data and how to put it together. So I'm going to go ahead and select person in the JSON-LD playground, and I get a starting point here. I'm actually trying to create a person, so that's great. And I've got my context and my type already set because I am using the person type from schema.org. So I'm going to do my snippet on Nelson Mandela. And so I'm going to start by changing the name. And I'm going to get to the job information in a bit. I know I'm not going to have a telephone number. And I'm going to do the URL next. So I'm going to move that up after the name. I'm going to fix my indent. I got to make sure to add a comment here. And I have to take out the comma after the job title. And so for the URL, let me look at the Wikipedia page, and I can just use this Wikipedia URL. Good a place as any. So I'll paste in that URL. And then I'm going to look at schema.org at person. There's a whole bunch of different pieces of information I could provide here about a person. I think birthplace is a really good common thing to include. And we do have a birthplace property. So over in the playground, I'm going to add birthplace. And for the value, I will look over in Wikipedia. Got born, and we got a description of the location. So I'm just going to grab this text here, and I'm going to put quotes in my snippet and paste that in. Take out that closing space and put a comma at the end. Now, one of the other things that's notable about Nelson Mandela in particular is that he was the president of South Africa. So I want to include an occupation. And so looking through the person type, we don't have an occupation option here. But I've poked through this a little bit, and there's a has occupation option. And when I click that, it tells me I can use role as the property to talk about past professions and dates. So I'm going to go back to the page I was on and look for role. It's not in person, and I don't see it in thing. But if I scroll down here to the bottom, I don't see it there either. So I'm going to do a search on this page for role, and there's the reference, use role for expressing dates. And then all of the other uses seem to be just talking about the word role. So let me do a broader search on schema.org, and I'll do a search in the search box here. See if I can find out about role. So here we go, role is another schema.org type. So I'm going to open that up. And so here I'm going to be creating a sub-object, it looks like. Now this is a situation where it might be useful to use a generator to see how this is done, but let's try it out. So back in the playground, I'm going to go ahead and take out job title. And instead, I'm going to put in has occupation, which was the key that was suggested by the description. And then for a role, this needs to be an object. And so within a sub-object, the first thing we need to do is specify its schema.org type. So I need an @type followed by role. And then I want to add properties and values for a role. So looking over at role, the properties specific to role are role name, start date, and end date. And that seems like a great set of data to include. So let me go ahead and just put those properties in first. Role name, start date, and end date. All right. So then looking back in Wikipedia, got President of South Africa. So I'll go ahead and use that as the role name in quotes, making sure I had that comma after it. And then for the start date, 10 May 1994, in quotes, and through 16 June 1999. So I have basic information about Nelson Mandela, and then I have information about one occupation, which is a role, and it has a role name and a start and an end date. I don't have any errors in the JSON-LD here, so the JSON-LD I've created here is valid. And again, I had to do a little bit of research and poking around on schema.org to understand what was possible and how to actually insert this subobject for has occupation and how to use the role type. So again, in situations like these, especially when you're working with a new type of information, using a generator or looking at examples and seeing how things fit together can be really helpful. So I'm going to take out this blank space here that I don't need, this empty line. Then I'm going to copy all this content to the clipboard. And back in my files for this video, I'm going to paste this into the person.jsonld file. And I'm going to save that. And now I have a JSON-LD snippet about a person. Thanks so much for joining me in this course. You now understand what JSON is and a few of the many ways that it's used to structure and exchange data. If you want to learn more about programming, check here in our library for a course on programming fundamentals. To learn more about how to share and access data on the web, try a course on APIs and web services. If you're interested in learning more about creating content that's easy for search engines to index, check out a course on search engine optimization or SEO. Feel free to